This is the day one where we are going to start with our IoT. The screen that is shared here, this is the day-wise content that we are going to give you in these 6 days. So the first day that we have started today, this is basically we'll try to understand what is Internet of Thing. And in this, we'll discuss that what is the thing, what are the reasons behind the trending of this thing. So we'll discuss various applications. So with this so we'll be going further in the second day, giving you the details about networking part and embedded systems and so on. In our coming third and fourth day, we'll be having a hand-on session on Arduino. And the fifth day, we'll be having Raspberry Pi. And the last day will be having a small, we'll try to make small project. You all will try to have a hand-on thing on a project. You all will try to implement all the knowledge that you gathered from us, you got from us, what you understood. We'll try to implement that thing. So let's start. Let's begin. Let's begin with the IoT. What the IoT is? So it is it is that thing which is transforming our world to a smart world. From those traditional ways, we are moving on to the smart ways. We are like we have various things at our home itself, like we have home automation system, we have different things, various appliances at our place that are smart now. So when we go out, we all have different like smart transportation, we have traffic monitoring, we have smart street lights. So where we have smart schools, we have smart healthcare. So we have IoT everywhere. When we say it is making our world smart. So let's learn what the IoT is. So when we say Internet of Thing, when we say Internet of Thing, it 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 starts with a thing. So we will start with a thing. This thing can be any of your thing. It can be any of your thing. So that your thing, it can be a IoT. It can be a IoT device only if it has certain capabilities, right? But that thing definitely can be anything except a computer or a laptop or a desktop or a server. A main computing device, we cannot call that it is a IoT device, because that is not the typical thing that has some other function or other thing that it has to do. It has some other dedicated function. Its function is not to compute, where the computer is to compute. I am talking about your thing. It can be any of your thing that we can call a IoT device. So I'll go by one example. Let's take this example as a refrigerator. So refrigerator. So uh, refrigerator. You all know, we all have refrigerators. We know when we keep the door open for a refrigerator, when we keep the door open, so we keep it open long time. There will be some kind of beep or the ringer that will be indicating that you forgot to close the door, isn't it? This happen? This is the basic thing that is almost there in all the refrigerators. We keep the door open for long, it will give you a beep. It will give you a ringer. It will give you some kind of indication, a signal that you forgot to close the door. Can I call that refrigerator a IoT device? But the actual answer is no. The answer is no, because that refrigerator, it has a ringer. That means it has a sensor. It has a sensor. We can call it a smart, and we can call it a smart. It has a sensor, but it is not a IoT device. It do not have any connectivity. It do not have network connectivity. So that case, I cannot call that refrigerator a IoT device, right? So refrigerator, in this refrigerator, you can have a sensor. Firstly, you try to understand sensor. Sensor is something that is from the distance of the door. It is indicating that you kept the door open, right? and that information is given to this computing unit that is computing that some kind of action need to be taken, right? Some kind of action need to be taken. So that ringer is there, or that beep is there, that sound is there, that buzzer is there, that is basically a actuator. That is a action that is being taken on that sensed data. That data is sensed that you kept the door open, and whatever data is sensed, that is on that basis some action is taken. That action is in the form of a ringer or a beep or any kind of indication it is. So that is a actuator, that is a indicating, that is a action that is being taken. But still I cannot call that refrigerator a IoT device, right? So now my device can have one more example I'll give. In that refrigerator, suppose there is a butter tray, and that butter tray is low, and that this image, that this picture that is there in your screen, though this refrigerator, this is typical traditional refrigerator that is with that sensor that is indicating that door is, you have kept the door open, or when you open the door the light will start on, the light will be on. There is one light inside that will be on. That is who is telling, that is sensor is there. But nowadays the refrigerators are coming like a display. There is one display. That display be indicating that this fruits are a quantity of fruits, the quantity of vegetables, or the quantity of the butter, the quantity of eggs. So that display is there, and that if suppose anything is low in quantity, we can set the threshold that this is the value, it should keep this value over here. If that values goes low than that, that means it should display. And in that display unit, it is indicating that you are low in butter, you are low in fruits, you need to place an order, right? That display unit is there. So if that display unit is there and it is indicating that you are low in butter, you are low in fruit, can I call that refrigerator a IoT? Still that device is not a IoT device, because it is me. It is me who is reading out that display unit. A human intervention is required, where I need to check that display that I am low in these things. I need to place an order. I need to go, I need to buy these things. So I am low in these things. Here I am involved, right? It is still not connected to internet. It do not have internet connectivity. Then the third thing, when it is connected to the network, and if it is checking that I am low in these things, and it is placing an order, it is placing an order for me, and all the things are at my doorstep without involving me, then I can call that refrigerator a IoT device. When it has sensing capability, when it has a computing capability, that means whatever data is sensed by those sensors, there is some unit present that is computing it, that is processing that data, and it is taking it is sending that thing through the network, it is sending it to the cloud, or it is some kind of decision making. Then only I can call that thing a IoT device. Let's begin with this another example where it is a car, where it is a traditional car is transformed to a IoT device. We know we have like different sensors present. So one sensor is indicating that you are low in fuel. That means some kind of indication, some kind of display will be there. One is indicating that you are not wearing the belt, right? Some sensor is there that you kept the door open. So there is a camera that is also a sensor that is giving that is helping you to park your car. It is giving you a view to so we have different units, and these different units have different sensors, and they are gathering the information. They all have different embedded system that is computing that information. So that device which have all these things, or nowadays all the cars are coming with these capabilities, that these basic sensors are all there in the cars. So can we call that car IoT device? car, we cannot still call this car a IoT device. But suppose you are getting late from the office, and you are getting late to get to the university or the college, and you can switch on the engine of the car. You can switch on your car from your room, from your living room. You can make your engine on that of the car that is parked in the garage. If it has some kind of network connectivity, then only we can call that car is a IoT device. This is the thing that I tried to explain. Sensing capability, it has a computing capability, and it has a network connectivity, right? It is a sensing capability, computing capability, and network connectivity. Any kind of network connectivity can be there, any kind of computing unit is there, and any number of sensors can be there in that. So we will define a IoT device having unique identities that can perform sensing, actuating, and monitoring capabilities. When they all talk to each other, when they all get connected to each other, when they all make a network, that interconnected things we call a Internet of Things. Which thing that has these capabilities? So firstly, we will move towards the sensing capabilities. Firstly, from where it get the sensing capability? That will be from the sensors. That will be from the sensors. There are multiple sensors which can sense any of the physical phenomena occurring around their environment. When I'm saying around its environment, that means it has a certain sensing range. Up to that distance only, it can sense any of the physical phenomena that is occurring. So it can be a temperature sensor, it can be a humidity, it can be a distance, it can be a pressure, it can be a position, it can be any kind of the physical phenomena. It can be any of the gas, it can be sound, it can be vibration. So any of such kind of physical phenomena that is occurring, if that component has a capability to mirror it, that thing, that component is called a sensor. And these sensors are there in IoT device, which is the reason for their sensing capability. This is through which they get their sensing capability. So this sensing capability, these IoT devices get from the sensors. So there are multiple sensors present in these IoT devices, due to which they have sensing capabilities. So when we say computing, second capability that I have told you, IoT device, that device will have a computing capability, is by embedded systems. When we say a computing, generally the computers are the thing that comes to our mind. That computer, it is a computing system, that is an embedded system, that is not that traditional computer. It is not a traditional computer, it is not a laptop, it is not a desktop, it is not that computing thing, it is not that computing device. It is embedded. It is embedded system. What the embedded system is, that system that is a dedicated or task specific computing unit. It is a task specific computing unit that is hidden into the devices. Otherwise, when it is a computer or it is a laptop or it is a desktop, that is there in front of you, and you can do whatever programming, whatever coding you want to do. You want to listen to music, you want to play any of the video, that you can do with your computer. But these embedded systems are not available for programming. They are hidden into the devices in the form of integrated circuits. When we say it is a embedded system, firstly you must be clear that it is hidden into the devices. It is not that big computer, it is there in form of ICs are the small electronic components that are hidden inside the devices. They are hidden into the devices, and they do dedicated tasks. They don't do general purpose programming as we do a general purpose programming on the computers. The embedded system, the ICs, they perform they are task specific. If any of the microcontroller, Again, I'm using a term that you might not be familiar with. When we say a computing unit, when we say a sensor is indicating that you are not wearing a seat belt, it is what it is doing. It is just computing that data that is linked to that sensor, which is indicating that you are not wearing a seat belt. There's another embedded system. There is another computing system. There is another integrated circuit that is linked to that sensor, which is indicating that fuel is low, right? That is giving, that is processing only that data which is task specific. It is giving you the action required. It is giving you indication about that thing that is only about the fuel is low, right? So it is doing a dedicated task. It is not a journal purpose, right? It is a computing unit that is present in form of integrated circuit. It is hidden into the devices. It is taking the data from the sensor. It is processing that data, and at processed data, whether it is to be communicated, any action need to be taken, that is on the basis of that processed data. They are always task specific, and they are very small in size, so they are many in number. They are hidden into the devices. Now comes the third thing, that is the network connectivity. So these are the three things that are there in the embedded system. This is your detailed lecture will be giving tomorrow. What are the embedded system? This detailed lecture will be there, but from my point, only the computing thing is done by the embedded system, and those embedded systems are called microcontrollers. Overview, or the main task is they are task specific. They do just one thing. If they are dealing with one thing, they don't do any other thing, right? So then comes the connectivity. We know when it is a network, it can be wired or it can be wireless, right? But generally in IoT, it is wireless medium, and wireless medium is generally a RF medium. It is RF radio frequency, right? 3 hertz to 300 gigahertz. This is a RF radio frequency band in which all kind of TV, radio, mobile, satellite, all these communications are RF only. So RF is a wireless medium, that is radio frequency medium. It is a wireless medium in which we have different standards. In this, you one me Bluetooth. So Bluetooth is a standard that is defined under this only. That is defined under this RF medium. Under this, we have different things. You look here, we have different things. We have different options. We have Wi-Fi, we have Bluetooth, we have Zigbee, we have LoRaWAN, we have, so all these are under RF. It is 3 hertz to 300 gigahertz. It is a RF, it is a wireless. Though we have other wireless mediums also, but they are rarely used. We have infrared rays, we have microwaves, we have ultrasonic, but they all have their different specific things. But for this type of communication, for this type of network that we are talking about here, RF is a medium. RF is a radio frequency band. Its range is 3 hertz to 300 gigahertz, and all different standards are defined under it. These standards are IEEE standards that are defined as Bluetooth, Wi-Fi, Zigbee, LoRaWAN. So all like we have different standards for mobile communication that we call 3G, 4G. If the three capabilities that I explained, if three capabilities, if sensors are there for sensing capability, if we have computed as an embedded system, we have certain ICs that are there with the sensors that are computing the data generated by the sensor. That means computing capability is there, and some kind of network connectivity is also there. When these three things are there, when these three capabilities are there, we call that thing as a IoT device, right? So here the question that we can raise, so these all are the things that we can call IoT devices, but you should be clear that when only these three capabilities are there, we can call these things a IoT device. I have explained only IoT device, that this is a thing that we call a IoT device. So we know nowadays we have smart watches that we can call a IoT device. They're connected to the network. They do different things. So all this we are going to start with what Internet of Thing. It is a term that is coined by this uh, entrepreneur, that is Kevin Ashton. He has given this name to the IoT, that is Internet of Thing. There is no such standard definition, but this is like a definition that I found most suitable. So the IoT is basically, it is extension of network connectivity and computing capability to the objects, to your things, to the items not considered to be computers, which are not computers, but they have sensors and they have a capability, they have a capability, they have computing capability, they have network capability. So that thing, that extension of the network connectivity and the computing capability to the objects, and when these smart objects, they require minimum human intervention. They collect data, they analyze data, they have management capabilities, they have decision making capabilities. So connection of such kind of things is called Internet of Thing, where it is one of the entity that we have discussed, IoT device. When such kind of things are connected to each other, when they talk to each other, they make their network, that we call it is an Internet of Things. So things which are with such kind of similar capabilities that I have explained. So let's proceed further. First thing, because I have given a stress on that, the computing is there, but it is not a computer. How that computing unit that is there in, that is embedded, that is hidden inside the devices, that is acting as a computing unit for IoT devices, that how it is different from that computer. Why I am again and again saying that it is not a computer? Because IoT devices, they are not to compute. Their main function is not to compute. So if we talk about a car, the function of the car will not never be a main function, will never be a computing. Its function is still the same. It is, its main function is still to drive, though it will have a computing capability, but that computing capability will be required on and off. It will not always required, but the main thing that is required, that car must be capable to drive, right? So the main task of the things that are in Internet of Things, their main task is not to compute, right? Their main task is not to compute, whereas computers, they have their dedicated task, that is to compute, right? Second thing is the computational intelligence. That computational intelligence that is there uh, in um, in these IoT devices, it is it is it is not as like of computer that can do multiple tasks. It can do only one. It is task specific. It, if it is processing one kind of data and it is processing it as per that code, we cannot do a multitasking with it. We cannot play like in computer we can do a different task, like, but in IoT device, that computing unit will have only one dedicated task, and it is special purpose, like it will do only that thing, right? The computer is general purpose. It can do all the things. It can, right now I'm giving a lecture, I can access my mail, I can play the music, I can watch any video. So all the things it can do for me. But the computing unit that is there in IoT devices, that will do only that one special purpose. It is task oriented, right? So the things, the computing units or the embedded systems or the microcontrollers which are hidden into the devices, they are less expensive. They are like they are not as costly as that of computers. So they are more compact, they are much smaller, so as compared to the computers. So the computing unit which is there in IoT devices, that is not a computer. So let's begin with the next thing. That is this is the one picture that I have kept in front of you. That what are the reasons that are leading to the adoption of IoT? So what are the things that are contributing? What are all advancements, or what all the things, what all the reasons that are the reason or that making this IoT so trending, or that is leading to the adoption of this IoT? The first thing that is given over here, it is ENAC is the first computer developed, and you can see in the picture it was very costly. It was in its cost was in millions. So then with advancement of technologies, now with like with 30,000 to 35,000 we can have a good laptop, right? But as I am talking about the IoT device, in IoT device, the computing is such a small unit. It is hidden into the devices. That computing unit is, again, if the Arduino will take as an example, that Arduino here, it is a microcontroller that is there in Arduino. So Arduino is the most commonly used platform. You know, its cost is around 200 to 300. So that is one of the reason that the cost of hardware electronic components is reduced to much extent in the recent years. So that is one of the reason that affordability is increased. So because the cost is decreased, the cost is reduced. Earlier, the electronic components were expensive, but now they are available at less cost. That is one of the reason. Second reason is reduction of size. The size of these electronic components is reduced to such an extent that they can be many in number, hidden into the devices. They can be embedded, they can be hidden into the devices, because they are now compact, they are very small in size nowadays. These electronic components are getting reduced in their size, so they are getting compact. Their reduction in size, it is the third main reason behind the adoption of IoT. That is internet access. Earlier it was not available everywhere, but now we all have internet access. The internet access has improved. That is the third reason. That is the reason behind the adoption of IoT. Then is data cost, that is linked to that network connectivity. It is like data cost is reduced to such an extent that we all can have access to that data, that all we are making all the different things at our place. We are making all the things connected to the network because data is available at less cost. It is, we are having a internet access, our data is available at less cost. These two are linked to that network connectivity. And when we say it is a sensors, it is a computing, that is embedded system, there three things are there. That is, their cost is reduced, their size is reduced, and the third thing is their computational ability is improved. So these are the different reason behind the adoption of IoT. These are the different reasons that are leading to the adoption of IoT. So let's proceed further. Pervasive. Pervasive is something that is unknowingly entering our life. It is entering into our life unknowingly. We might not be aware of that thing, but it is everywhere. It has entered our life. So this, I have taken an example that at home the things are looking you, the things are monitoring you. When you go out, the things are there. When you go to your workplace, the things are counting how many have entered, when they have left. So when you are going to a mall, there different things are monitoring. So different. So it has entered. It is pervasive. That is, it is everywhere. It has entered our life unknowingly. It is entering into each part of our life. Wherever we are going, it is following us. So that is it is everywhere. That is the first thing. Second thing is, it is powerful. When I say powerful, so here I have kept one example for you, that we can have access Netflix. We have we can have access to any of the recently or any old movie, but those movies are not residing on your TV. Those are not in residing on your TV, but you can have access to different movies that are there on the server. So this is the thing that IoT is, through that connectivity, it is so powerful that it can give you an answer from anywhere around the world, right? So if you ask something to a Siri, the Siri is not the one who is having all the answer. What Siri do? Siri will look for the most appropriate answer. It with your words, what you have asked, it will check the server. It will go to that big server. It will look for the different answers available, and it will choose the most appropriate answer to your question. So though Siri do not know the answer, but Siri is connected to such a good server, it's a big server, that it can give you any of the answer that you have asked, any of the answer, that information is there around the any corner of the world. So how this is the thing that is, this is that it is interfaced to the cloud. So it is giving you the answers that it is finding from anywhere, right? So that is why it is very powerful, because it has interface to the cloud, right? Under the nature of IoT, I've explained that it is pervasive and it is powerful. Then when we go to the next thing, we will learn a societal impact of IoT. So here from this picture, what I have written that we are very near to the information, but we are away from the people. So first example that I took that a refrigerator which can check for the things, which can place an order, and all the things will be at your doorstep. In that case, you might have missed going out. You might have accompanied by your friend. You might have gone to the grocery store. There you might have met many people. So we are going away from the people, but we are going very near to the information. I can have access to I can ask any of the question. I can find out any of the answer from, I can find out that thing from anywhere around the world. I can have an answer. I can have a information that is published anywhere around the world. I can have a access to that information. But I don't know. But sometimes we are not that. This is in general the impact of technology. We can say that we are going away from the people. This is a societal impact of the thing. Though we are very much connected, we are very much connected. We are very much near to the information, but somehow we are going away from the people. The second thing, that second societal impact is when we say that we have different things, we have less visit to the doctors. That means there are different gadgets that can monitor our health, and we can have a basic checkups at by ourselves. We can have that basic. Earlier we could not do this. Now we can have all the gadgets. Even our watch can do the ECG. So we can have but that thing is, we are more dependent on these gadgets. We are nowadays we are dependent. That means if any of this thing is giving you a false is giving you a wrong reading, or that may put you in a trouble. So that is one of another impact of the IoT, that we are we are getting dependent on these gadgets, right? So let's proceed further. So let's try to understand a bit technical part, that is characteristics of IoT. This is a bit important thing. Try to understand. First thing, I'll say the first thing, that is intelligence. What is the thing that is giving intelligence to IoT? It is a computing capability that is giving intelligence. Those sensors are sensing, but that sensor is sensing whether you're wearing a seatbelt or you're not wearing. If you're wearing, it is okay, and if you're not wearing, then only it will indicate you, right? So it is how that computing capability is making sense out of that data which is sensed by the sensor. Whatever data that sensor has sensed, who will make a sense out of that data? Who will extract the information from that data? That is a computing unit. That is a intelligence. That is a intelligence, right? It has a computing unit due to which it has intelligence. Second thing is sensing. Sensing, I hope you understand, it has many sensors. They can sense the physical phenomena. So when we say connectivity, that is the third thing. It has a network connectivity, has but whatever it has processed, that information can be communicated. It can be stored somewhere, or any of the decision can be taken, or it can be kept as a data to take a decision in the future for the decision making, or at the same moment some action can be taken, right? Any kind of the thing can be there depending upon what the data that is being processed, right? So then is dynamic nature. When you say dynamic, one thing is static and one is dynamic. Static is like computer, it keep on computing all the time. That is, it is doing that thing all the time. Dynamic is the devices are not always active. The devices are not always. If it is about the seat belt, or if it is about fuel is low, or about the refrigerator is placing the order, all the time it is not computing. So dynamic means it is somewhere, sometime it has something to send, other time it may not have anything, right? One time it is behaving as if it is sending some data, it has something to send, other time it may be sleeping. So when I say active and sleep, there is a reason behind that, why these devices has to act in that way. That in coming lecture I'll be explaining that also, because when we say IoT devices, these devices are generally mobile in nature. They keep on changing their location, not static in terms of their location. If it is about the appliance, they may be fixed at the place, but there are many other devices which we consider which are mobile in nature. They keep on changing their location. When they're changing their location, that means they are powered by battery. So when it is a battery, they are battery operated devices. Battery means it is a limited power. It is a limited power. So that power must be used efficiently. It is not all the time they'll be active, otherwise that battery will get drained out. So if you put a tab, or if you tap a watch, or if you have any notification, only then it will consume the power. Rest of the time it will be sleeping, because it has to use that power efficiently. Power is not unlimited. It is not plugged into, if it is mobile in nature all the time, it is not plugged into the supply. In that case, it has that limited source of power. It has a battery that it has to use efficiently, right? That it has to use efficiently. So this is a dynamic nature. Then is vast scale. Vast scale is that there are many devices, and it is everywhere. It is there are number of things which are a part of the internet of things, so its scale is vast, right? So then is heterogeneity. Heterogeneity, all the different things which have those capability, they all can communicate with each other, but they all have different computing unit, they all have different sensor, they all have their own different task, but they all have to make a network, right? So that difference in the senses, that difference in their behavior, that difference in their computing, that is the thing, that is heterogeneity. They all are different from all the things, are not the computers which are connected, which are making a network. It is that those things are different to each other, and they all those things are making a network. So this is what that is heterogeneity. I have kept many more things for you that I have to continue in my next class.
So today I am going to discuss some of very few topics about IoT and the important components or the hardwares or the softwares that are related to IoT with respective to the physical world, and the most important term called embedded systems. So this could be the agenda of our day. There are different types of Arduinos, and this is one of the Arduino. Next, it is Raspberry Pi. This hardware is called Benzal board.